Alright, so this is the 4.4 through 4.5 test review. So, which quadrant does theta lie in? So that we have to use our all students take calculus. So in the first quadrant, all of our 6 trig functions are positive. The second quadrant, just sine and its reciprocal, so that would mean cosecant as well, are positive. The third quadrant, tangent and its reciprocal cotangent are positive. And in the fourth quadrant, cosine and its reciprocal secant are positive. So this says cosine is less than 0, meaning that it's negative. So we can automatically cancel out 2 of them. So if cosine's negative, we can't be in the all positive one, and we can't be in cosine positive one. So we can cancel out those 2. If cosecant is positive, well, cosecant's not going to be positive in the tangent quadrant, so that leaves us with quadrant 2. So theta is in quadrant 2. For number 7, cotangent of theta is greater than 0, so we have all students take calculus. If cotangent's positive, that means we can either be in the tangent one or the all, so I can cancel out the sine quadrant and the cosine quadrant. And then if secant is positive, I'm not going to be in tangent, because only tangent and cotangent are positive in tangent, so that means I have to be in quadrant 1, the all. Number 8, doing the same thing. All students take calculus. So if sine is less than 0, that means sine is negative, so I'm not in the sine quadrant and I'm not in all. If secant is greater than 0, that means secant is positive. Secant goes with cosine, so I am not in tangent, and that means I'm in the fourth quadrant. So just as a reminder, just like how you go all students take calculus, in that order you have quadrant 1, quadrant 2, quadrant 3, quadrant 4. Alright, moving on to number 9. Given that sine of theta is negative 4 over 9 and tangent of theta is less than 0. So we're going to need to know which quadrant this lies in to see which of our trig functions are positive and which are negative, so the signs of all of them. Sine, we know, is opposite over hypotenuse. So in our triangle, if this is theta, negative 4 as our opposite, and then our hypotenuse is 9, so we have to find our adjacent. So we're going to do Pythagorean Theorem. So I have negative 4 squared plus x squared is equal to 9 squared. So this would be 16 plus x squared is equal to 81. Subtract 16 on both sides, so x squared is equal to 65, and take the square root. So x is equal to the square root of 65. Always check to make sure you can't simplify your radical. Here, our only factors of 65 are 13 and 5, which are both prime numbers, so can't simplify. So our adjacent is square root 65. So let's find our trig functions. Sine of theta, which was given to us, is negative 4 over 9. So that means cosecant theta is going to be the reciprocal of it, so negative 9 over 4. Next I have cosine theta. Cosine is adjacent over opposite, so that would be square root 65 over 9. Secant theta is going to be the reciprocal of that, so that would be 9 over square root 65. Multiply the top and the bottom by square root 65 because you have to rationalize. So this would be 9 square root 65 over 65. Then we have tangent theta. So tangent is opposite over adjacent, so that would be negative 4 over square root 65. Have to rationalize, so multiply the top and the bottom by square root 65, and this would give us negative 4 square root 65 over 65. And then lastly we have cotangent, which we would just take the reciprocal of tangent, so that would be square root 65 over negative 4. It says tangent is less than 0, so we have to figure out which quadrant this is in just to double check our sign. So we have all students take calculus. Sine is negative, so I'm not in all and I'm not in sine. And tangent is negative, meaning it's less than 0, so negative. So I'm not going to be in the tangent quadrant. So I'm in the fourth quadrant, so only cosine and secant are going to be the positive ones. So double check, make sure everything else is negative besides cosine and secant. So I have a negative here, negative, and negative. So cosine and secant are positive. So let's look at number 10. So cotangent is, because we have TOA, it's the reciprocal of tangent, so this would be adjacent over opposite. So in my triangle, if this is theta, adjacent is 10, opposite is 3, and my hypotenuse is, I have to find it using Pythagorean Theorem. So 3 squared plus 10 squared equals x squared. 9 plus 100 equals x squared. So x is equal to the square root of 109. So that is my hypotenuse. So I have to find my trig functions. I have sine of theta. Sine is opposite over hypotenuse, so that would be 3 over square root 109. Again, double check to make sure you can't simplify square root 109. We can't. So next we would rationalize, multiply the top and the bottom by square root 109. So this would be 3 square root 109 over 109. We're not sure if it's positive or negative. At the end, we'll double check the signs. So the reciprocal of sine would be cosecant. So I would flip the unrationalized one just because I don't want to have to rationalize it again. So this would be square root 109 over 3. Next, I have cosine. Cosine is adjacent over hypotenuse, so that would be 10 over square root 109. Rationalize to get 10 root 109 over 109. And then its reciprocal would be secant. So flip the unrationalized one because we don't want to have to rationalize again, so that would be 109 over 10. Next, I have tangent of theta. Tangent is opposite over adjacent, so that would be 3 over 10. And then cotangent was given to us as 10 over 3. So let's double check to make sure our signs are what they should be. So I have all students take calculus. Cotangent is positive, so that means I'm not in the second quadrant, I'm not in the fourth, because I have to be in the tangent quadrant or in the all positive quadrant. Sine is less than 0, so that means it's negative, so I'm not in all, so that means only tangent and cotangent are going to be the positive ones. So I have to make everything else negative. So sine's going to be negative, cosecant's negative, secant's negative, cosine's negative. Only tangent and cotangent are going to be the positive ones. So always make sure you go back in and check your signs at the end. Or you can do it in the middle. Alright, let's find our reference angles. So depending on which quadrant you're in, depends on which formula you would use to find your reference angle. If you're in the first quadrant, your reference angle, so theta prime, is going to be equal to theta. If you're in the second quadrant, your reference angle is going to be 180 minus theta. Third quadrant, your reference angle is theta minus 180. And in the fourth quadrant, your reference angle is 360 minus theta. Two things to note about your reference angle: it is always positive, and it is always acute. so it's always going to be less than 90. The reference angle is the distance from your terminal side to the horizontal axis. So if I had an angle theta that ended here, my reference angle would be from the terminal side to the horizontal axis. So this would be theta prime. So it always goes to the horizontal axis. So let's find the reference angle for 11. So here, 123 degrees would be in the second quadrant. So I'm going to use the formula 180 minus theta, which is 123. 180 minus 123 is 57. So theta prime is 57 degrees. If your reference angle is given in degrees, you have to make sure that your answer is given in degrees as well. Number 12. So theta is 265. So here's 90, here's 180. 265 would be somewhere in the third quadrant because next we would get to 270 and it's not quite 270. So we're in the third quadrant. Third quadrant means I'm using the formula theta minus 180. So this would be 265 minus 180. 265 minus 180 is 75. 85. So theta prime is 85 degrees. Again, theta is given in degrees. My answer has to be in degrees. All right, moving on to 13. So here theta is pi over 6. If you know where pi over 6 is, perfect, awesome. But if you don't, you can always convert it to degrees to then tell what quadrant it falls in. So I'm going to multiply by 180 over pi. Pi's cancel. 6 goes into 180 30 times. So this is 30 degrees. So this falls in our first quadrant, and our theta prime, our reference angle, is the same thing as theta in the first quadrant. So theta prime would be 30. However, the question gave us radians, so our answer has to be in radians. So theta prime is pi over 6. So it's the same thing as theta when it's in the first quadrant. 14. I don't know where negative 7 pi over 3 is, so I'm going to convert it. So multiply by 180 over pi. Pi's cancel. 3 goes into 180 60 times. Negative 7 times 60 would be negative 420. This is negative, so I could just know that I'm going to go in the negative direction around 360, and then I have more to go, so I would add 360 to this to find a coterminal angle of it. This would be 60, negative 60. And then I'm going to add 360 again to find a positive coterminal angle, because if I'm going to plug it into one of the formulas, it has to be positive for it to work. So negative 60 plus 360 would be 300. So 300 falls in the fourth quadrant. So in the fourth quadrant, I'm going to use the formula 360 minus 300. So that would give me 60 degrees as my reference angle. But the question gave me radians, so my answer has to be in radians. So I'm going to multiply by pi over 180. So 60 goes into 180 3 times, so this simplifies to pi over 3. So that is my reference angle. $15. Again, don't know where 12 pi over 5 is, so I'm going to multiply by 180 over pi. Pi's cancel. 5 goes into 180. Let's see, 5 goes into 18 3 times with 3 left over. And 5 goes into 36 times, so that would be 36. 12 times 36 would be 360 plus 72, so that would be 432. Yep, degrees. So 432 goes around the circle once, and we're going around more, so I want to find a coterminal angle, so I'm going to subtract by 360. This leaves me with 72 degrees. So 72 falls in the first quadrant. So I know I'm going to be in the first quadrant, so my theta prime is going to be the same thing as theta, but my question gave me radian, so I have to convert this back to radian. So I'm going to multiply it by pi over 180. 9 goes into 72 and 18, so 9 goes into 72 8 times, 18, 180 goes in 20. I can also divide these both by 4, so 4 goes into 8 2 times, 4 goes into 25 times, so this would be 2 pi over 5. That's my reference angle. Alright, looking at 16 now. Use reference angles to evaluate all 6 trig functions. So I need to find my reference angle, so first thing I have to do is figure out which quadrant this is in. So I'm doing the same thing I was doing before, but now I'm just adding the step of evaluating the trig functions. So I need to multiply this by 180 over pi to figure out which quadrant I'm going to be in. Pi's cancel, 4 goes into 180, 45 times. 9 times 45 is 405, so this is 405 degrees. So this goes around the circle more than once. To find how much more I'm going around, I can subtract 360 from this to find a coterminal angle. So I'm left with 45 degrees, so I'm in the first quadrant. So in the first quadrant, my reference angle is going to be 45 degrees. So I'm going to redraw that to make it a little bit better for you guys. So I'm looking at 45 degrees in the first quadrant. So here I have a 45, 45, 90 triangle. So 45, 45, 90. My legs are going to be, I know Miss Meadows does it as like 1, 1, and square root 2. I do it as x, x, x square root 2, so the x's will cancel. But it's the same thing, you'll get the same answers. So finding the sine of theta, which theta is 9 pi over 4, we're using 45. So sine is opposite over hypotenuse, so that would be x over x square root 2. The x's cancel, so this is 1 over square root 2, and you have to rationalize, so multiply the top and the bottom by square root 2. You get square root 2 over 2. Next, we can find cosecant theta. Just take the reciprocal of sine, so that would just be square root 2. Eventually, we will have to find the signs of all of these, so whether they're positive or negative, but we just have to do that at the end. However, since we are in the first quadrant, we know we're in all, so everything's going to be positive. So next we can find cosine. Cosine is adjacent over hypotenuse, so adjacent to 45 would be x, and the hypotenuse is x square root 2. So the x's cancel, so 1 over square root 2, which rationalizes 2 square root 2 over 2. And then the reciprocal would be secant. So we just flip the unrationalized ones. That would be square root 2 over 1, or just square root 2. And then lastly, we have tangent. Tangent is opposite over adjacent, so that would be x over x, which simplifies to 1. Cotangent is the reciprocal, so that would be 1 as well. And then we said since this is in quadrant 1, everything is positive, so all of these signs are good. So let's go to 17. So we have to find the reference angle first. Negative 300, we go in the negative direction, and we end up in quadrant 1. We can find what the coterminal angle of this is by adding 360. So that would be 60 degrees. So we're looking at a 60 degree angle here. So we know opposite of 60 is x square root 3. Opposite of 30 is just x, and our hypotenuse is 2x. So to find our trig functions, we have sine, which is opposite over hypotenuse. Ooh, opposite over hypotenuse. So x square root 3 over 2x. The x's cancel, so square root 3 over 2. The reciprocal cosecant, we just flip it. So 2 square root 3, 2 over square root 3. We need to rationalize it. So this would be 2 square root 3 over 3. Next we have cosine. Cosine is adjacent over hypotenuse, so adjacent of 60 is x over 2x. The x's cancel, so 1/2. So the reciprocal of that would be secant theta. So flip 1 over 2, that would be 2 over 1, or just 2. And then lastly we have tangent. Tangent is opposite over adjacent, so x square root 3 over x. X's cancel, so just square root 3. And cotangent would be the reciprocal, 1 over square root 3, have to rationalize, so square root 3 over 3. We are in the first quadrant, so everything is positive. So these are our answers. We don't have to change the signs of anything. All right, 18. We need to find the reference angle first. So I don't know where 13 pi over 6 is, so I'm going to convert it to degrees to help me figure out what quadrant it's in. So I'm going to multiply by 180 over pi. Pi's cancel, 6 goes into 180, 30 times 13 times 30 is 390 degrees. So I go around the circle once and a little bit more. So to find what the coterminal angle of this is, I'm going to subtract 360. So that would give me 30 degrees. So I'm 30 degrees from the horizontal line here. So theta is 30. So opposite of 30 is x. Adjacent to 30 would be x square root 3 because that's going to be opposite of 60. And then the hypotenuse is 2x. So first we'll find the sine. Sine is opposite over hypotenuse. So x over 2x, x's cancel, that would be 1/2. The reciprocal of that would be cosecant, so that is 2. Next we have cosine. Cosine is adjacent, so x square root 3 over 2x, adjacent over hypotenuse. The x's cancel, so square root 3 over 2. Secant is a reciprocal of that, so 2 over square root 3. We have to rationalize, multiply the top and the bottom by square root 3, so 2 square root 3 over 3. Lastly is tangent. Tangent is opposite over adjacent, so x over x square root 3. X's cancel, 1 over square root 3. We have to rationalize, so square root 3 over 3. Lastly, cotangent, just take the reciprocal of the unrationalized one. So 1 over square root 3 flips to square root 3. Since, again, we are in quadrant 1, all are positive in quadrant 1, so we don't have to change any signs there. So these are our answers. Alright, so for 19, 20, and 21, we have to find the amplitude, time period, phase shift, vertical shift, starting point, and reflections. So it helps to label your A, B, C, and D. So we have A first, B, C is what gets added inside the parentheses, and then D is what gets added outside. So A is our amplitude. Amplitude's always positive, so that would be a positive 2. Time period. So our period is 2 pi over b. B here is 2 over 3, so this would be 2 pi over 2 over 3. So keep, change, flip. Keep the top, change to multiplication, flip. to 3 over 2. So this would be 6 pi over 2, which simplifies to 3 pi. So our time period is 3 pi. Phase shift is C. So here that would be none, no phase shift. Vertical shift is your shift up and down, so that would be D. So we have none for this one also. Starting point is C over B. So C is 0, B is 2 over 3. So 0 divided by anything is still 0. So our starting point is at 0. And then lastly, we have reflections. So the negative out front is a reflection on the x-axis. So reflection on the x-axis. All right, number 20. So we have A, B, C is what gets added inside the parentheses, and D is what's added outside. So amplitude, we have no amplitude, so that would just be 1. It's not 0, because if you multiplied sign by 0, the whole thing would be 0. So amplitude is 1. Time period is 2 pi over B. So 2 pi B here, we don't have anything getting multiplied to x, so that would just be 1. So 2 pi over 1, which is just 2 pi. Phase shift is our C. We don't have a C here, so that would be none. Vertical shift, that's the D. So that would be 2 here. Starting point, C over B. So C we said was 0, and B is 1. 0 over 1 is 0. And then we're not multiplying anything by a negative here, so there are no reflections. Right, 21. We have A, B, C, and D. So amplitude is our A. Amplitude, always positive. So that is 1/3. Time period is 2 pi over B. B here is 2. So this would be 2 pi over 2, which is just pi. Phase shift is C. So that would be pi over 3. Remember, you always have to change the sign of your C. So it would be positive pi over 3. Vertical shift is D. So here we're not adding anything on the outside, so we have no vertical shift. Starting point is C over B. C is pi over 3. B is 2. So keep, change, flip, keep the top. Change, multiplication, flip 2 over 1 to become 1 over 2. So our starting point would be pi over 6. And then reflections, because we have this negative on the outside, we have a reflection on the x-axis. If the negative were on the inside, like negative there, that would be a reflection on the y-axis. So that's an example of reflection on the y-axis. But most of the time we see it outside, so it's a reflection on the x-axis. All right, let's graph. So in graphing, we want to find A, B, C, D, our starting point, which is C over B. The period, which is 2 pi over B. And then the increments, which is the period divided by 4. So we have A, B, C, D. A is our amplitude. Amplitude's always positive. We don't have a number being multiplied to sign here, so amplitude is just 1. B comes next, so that would be 3. C is what gets added inside. Always have to change the sign of C, so this would be negative pi over 2. And then D is 0. So our starting point is negative pi over 2 over 3. Keep change flip. So we're starting at negative pi over 6. So I'll put a tick mark there, negative pi over 6. Next, the period is 2 pi over b, and b here is 3. We use that to find our increment, so we just take the period divided by 4. So 2 pi over 3 divided by 4, keep change flip. Keep the top, change multiplication, flip the bottom. So multiply by 1 over 4, this becomes 2 pi over 12, which simplifies to pi over 6. So we add pi over 6 to get to our next tick mark, the next one, the next one, the next one. You got to add it 4 times because you need a total of 5 points. So your starting point and 4 more. So negative pi over 6 plus pi over 6 would be 0. So our next tick mark is at 0. 0 plus pi over 6 would be pi over 6. Pi over 6 plus pi over 6 would be 2 pi over 6, which simplifies to pi over 3. And then pi over 3 plus pi over 6 would be pi over 2. And because this is a sine graph, we start at 0. However, it's negative, so we have a reflection. So instead of starting at 0 and going up to our amplitude, which I have to put my amplitude at 1 and negative 1, so instead of going up in the positive direction, since it's negative and I have a reflection, I'm going to go down to my negative amplitude. Then I go back to 0, up to positive 1, then back to 0. So that is my sine graph. Alright, let's do the same thing for the next one. Here we have cosine, so I need to find A, B, C, D, starting point, period, and increments. So we have A, B, C, D. So A is 1/2. That's my amplitude, so I'm going to go up to 1/2, down to negative 1/2. B is what gets multiplied to x, so that would just be 1. C is what gets added to x, but you always have to change the sign, so this would be pi over 5, positive pi over 5. And D is what gets added outside, so that would be 0. Starting point, C over B, so that would be pi over 5 over 1, so just pi over 5. So I'm starting here at pi over 5. The period is 2 pi over b, which b here is 1, so 2 pi over 1, which is just 2 pi. Increment is the period divided by 4. So that would be 2 pi divided by 4, which is pi over 2. So pi over 2 is what I'm adding to get to the next tick mark, the next tick mark, the next tick mark, the next one. 4 times, because I need 4 tick marks after the starting point. So I have pi over 5 plus pi over 2. When adding fractions, I need a common denominator, so I'm going to multiply the first one by 2 over 2. So change that to 2 over 10. Second one, I'm going to multiply by 5 over 5. So that becomes 5 over 10. So 7 pi over 10. So then I take 7 pi over 10 and add my increment again to it, so that would be pi over 2. Again, need a common denominator. I'm going to multiply pi over 2 by 5 over 5, so it becomes 5 pi over 10. 7 pi plus 5 pi is 12 pi over 10, which simplifies to 6 pi over 5. So next I have 6 pi over 5. I need to do the same thing again. I'm going to add my increment again. So So 6 pi over 5 plus pi over 2. Need a common denominator, so I'm going to change this to 12 pi over 10, and this becomes 5 pi over 10. So 12 plus 5 is 17 pi over 10. 17 pi over 10. And then lastly, do it again. 17 pi over 10 plus pi over 2. Need a common denominator, so multiply this by 5 over 5. Get 5 pi over 10, 5 plus 17 is 22. So 22 pi over 10, which simplifies to 11 pi over 5. So those are my increments. Since this is a cosine graph, I'm starting at the amplitude. So at my starting point, I'm starting at the amplitude. From the amplitude, I go down to 0, then down to my negative amplitude, back to 0, and then back up to the amplitude. So this is my cosine graph.